Hi, everybody. Welcome to our library discovery hour. Thank you for joining us today. I'd like to extend a special thanks to our friends of the library for their generous support every year. I'm Michelle Colley. I'm the Associate University Librarian for Health Sciences and the Director of the Health Sciences Library. We're excited to be hosting this new Library Discovery Hour series that gives you an up-close look at the university libraries and a chance to meet the librarians, archivists, and staff behind every story we share. Today's program is the final of 4 Discovery Hours planned between October and May. And we're thrilled to have so many of you with us on the call today. So settle in for the next hour with your lunch if you're on the East Coast, or your coffee or tea if this is early morning for you on the West Coast. And I'm going to set the stage a little bit for today's webinar before we jump in. Last spring, actually, let me go ahead and share my screen first. Okay, y'all should be seeing my slides. Last spring, our university librarian, Maria Estorino, engaged with a small team in the libraries to define our strategy with respect to generative AI, or GenAI. From that effort came a GenAI roadmap, and the purpose of the roadmap was to help us understand where we are and where we wanted to go. In the last year, we've made significant progress in several areas related to staff readiness, how we do our work, and how we partner and support our patrons. I also want to say what we're not doing, which is saying that anyone should use this technology. Like many of you, our staff are aware of the social and environmental implications of GenAI. We strive to ask ourselves, do we have to use GenAI for this task? What other options might be available that might not have the same impact and cost? So I just want to lay that out there. As part for the GenAI roadmap, we have 3 areas where we're engaging. The first is workforce readiness, staff readiness. To serve campus, our staff needed to get up to speed on GenAI so that we can support research and instruction and also realize operational efficiencies in our own work. The pace of change is fast, and it's easy for you or our staff to feel like you're already left behind. So we really wanted to focus on learning and bringing staff along. Nobody's really behind. It's really very new technology. For that effort, we've done quite a few things. We set a library-wide performance goal that staff could use in their performance plans last year, and we'll likely do the same thing this year. We have created a staff-focused GenAI guide that really curates lots of opportunities and webinars and resources for staff to use in their learning. We set up a library's GenAI fund, and this is basically for staff to propose that they would like to trial or test out a different tool to sort of see how it might apply for their work or help them learn about it so that we can share it with our patrons. We've set up learning communities, and we have lots of projects underway. So there's lots of work that's been done in that area. We also are thinking about operational efficiency. So we're thinking about how does GenAI affect how we may do our own work. So we're testing that and considering how might we do our work differently. Where does GenAI offer us opportunities to do our work more effectively or more efficiently? And I think some of the lightning talks that you're going to hear today will touch on this. And lastly, probably, really most importantly, is how are we supporting campus? And that's really kind of our ultimate goal, in addition to doing our work more efficiently. So lots of different ways that we're doing this. We've created a guide that is very focused on supporting our students on our campus as they consider using GenAI and how to use it. We've done lots of teaching. I think we've probably reached more than 700 or 800 learners in a variety of workshops and course integrated instruction over the past year. And we do consultations, we're working on projects, and some of you may know we're also going to be launching an AI studio in fall of 2025. So that the studio space will be on the second floor of Davis Library. It will be open to all UNC affiliates. And we really see it as being a barrier-free space where users can gather, learn, and create to learn about the basics of GenAI. So that's what we'll be teaching through the AI Studio. It's sort of a sandbox environment that we're imagining, so they can experiment with a variety of tools and then connect with knowledgeable staff. So we've done a lot of staff training. So our staff, I think, are very prepared to support our campus. So today you're going to hear from 3 of our library staff members from across the university. Stop sharing. from across university libraries, and they're going to spotlight how they're using GenAI to change how we do our work and support our patrons. In brief lightning talks, they're going to share how the university libraries is engaging with and really leading on the use of GenAI at Carolina. So a few logistics before we jump into our lightning talks. Each presenter will present for 10 minutes, and then we're going to open up for 5 minutes of Q&A. You can submit your questions in the Q&A box at the bottom of your screen anytime during the presentation, and we'll try to answer as many as possible. And again, we're going to do questions for each speaker directly after their talk versus waiting to the end. So I'm going to turn it over to our first speaker, Adam Dodd. And Adam will talk about how we're using a tool called Julius AI in his work at the Health Sciences Library.
Thank you, Michelle. Give me just 1 second. Okay, can everyone see my slides?
Yes.
Okay, thank you. Okay, I will be speaking with you today about Julius AI and how we are using Julius for our work around library impact measurement and visualization services, primarily at the Health Sciences Library in Health Research Services. So just an overview of the things that will be presenting. I will be talking with you about Julius, just giving a brief overview. I will talk a bit about our services, and then I will talk with you about how we've integrated Julius into our services. And then we'll have time for questions at the end. So first, an overview of Julius. So what is Julius? Julius is an AI tool that is specifically designed for and to support data analysis work. Julius can handle all sorts of data inputs, spreadsheets, structured data such as CSV files. It can also search the web to extract and import data. And the goal of Julius is to, as their tagline says, turn data into insights, and that is both structured and unstructured data. One of the strong points for Julius and supporting Julius in terms of our services is that Julius offers both free and paid account access, and also offers a wealth of documentation around the tool, as well as YouTube tutorials and community forums for requests for assistance. So how is Julius different than some of the other GenAI tools that are available? So first off, upon prompting in Julius, Julius can build and execute code. Again, thinking through the lens of data science and data analysis tasks, the code that is provided is primarily Python and R, and it works directly within a virtual environment with libraries that are supported within Python and R. Julius can process and analyze large data sets quickly, although the file sizes that are supported may vary from account types, free versus paid. And Julius uses a large number and has incorporated a large number of large language models so that it may direct to the appropriate model depending on the type of data that is being analyzed and the types of tasks that are being undertaken. Here are some examples. So as I said, many different large language models are supported. So various versions of OpenAI, various versions of Claude, as well as other examples like O1, O3, etc. And then, as I stated, the sort of call and response through the prompting engine within Julius, you will provide your data, you will provide a prompt within Julius, and then Julius will choose which large language model should respond based on the tasks that you have outlined. and then we'll build and we'll generate code for you either in Python or R. Julius also supports workflows. And as you can see just on some of the examples here, all things data are supported, right? So data cleaning, data preparation, data processing, visualization, and we'll look at some of those a little closer, as well as both general and advanced statistics. Here are some of the examples of the data processing workflows that are available through Julius. So we see here, these are very common tasks when working with data. So data cleaning, data preparation, combining data from multiple data sources based on unique identifiers and deduplication of data. Also data visualization. So inherent to Julius is the capability to build plots, various plots, charts, graphs, etc. And those, depending on the type of visualization that is generated, those can be interactive as well as static. Here are just a couple of other examples, as well as just a quick view within Julius. So at the bottom of the screen on either side, you can see the examples of the prompt mechanism, as well as the response for Julius, in this case, providing Python code first, then running that Python code to provide responses, and then some examples of visualizations. Julius also supports custom workflows. The workflows within Julius that are supported, anyone can use at any time. You can also either build your own workflows, either through your iterative prompting, and then decide upon success that you wish to convert that prompt string into your own workflow so that you can repeat that process for automation. You can also use the existing workflows as an effort to take advantage of the community workflows that have already been constructed, either by using them directly or manipulating them in some way so that they fit your specific needs. So let's talk a bit now about our services, as well as how we have integrated Julius into our workflow. So I work in the Health Research Services group within the Health Sciences Library. Our primary goals are to help researchers across the university, students, faculty, staff, as well as administrators to be able to identify within data sources patterns, trends, and gaps in unit-supported research, education, and clinical care activities. We certainly work to measure and assess research impact around discipline areas. We communicate research impact to external audiences, typically stakeholders internal or external to the university, as well as working on grant submissions. And we also help to discover patterns in research collaborations or to across researchers, institutions, or across countries, as well as finding potential collaborators. Here are some of the data types that we typically work with. Again, we're in the library context, so we're working with publication citation data from various publication data sources. We're working with grant reward data that is available to us from the federal government or other entities that provide that data to public audience. We can also work with patent data or altmetric data, so things like social medicine policy documents, clinical guidelines, etc. Just on the left here, some other examples of our visualizations from past projects. And now let's talk a bit about how we've integrated Julius into our workflow. So these are just a couple of the areas, general areas where we have integrated Julius. We are using Julius I'll speak a bit to sort of our approach in just a moment, but we're using Julius for some of the tasks that we do on a day-to-day basis, but take a significant amount of resources, so either time, effort, etc. So in terms of data analysis, analyzing, cleaning, and cleaning data, performing some low-level statistical analysis or descriptive analysis of data sets, as well as creating some basic visualizations. Anything that has to do with providing a expedient insight into a research data set, so summarizing academic papers, generating citations, performing literature, again, quick automated literature reviews, synthesizing information. So this would be as a facilitation for manual screening or manual review. And then working with unstructured data for natural language processing, looking within those publications to extract components from research publications. And these are just some very fast examples in terms of how we're working with faculty, staff, and students to support those research needs, right? So as use case one suggests, as I've already pointed out, working with faculty, researchers who may want to perform bibliometric analyses or some type of more structured research review on a particular topic, either for peer-reviewed publication or just for their own edification. Working within the library to identify trends in research, identify key researchers, so to support existing and perhaps future research projects across campus. Certainly working with students, so for professional development, understanding not just data analysis, but some of these nascent generative AI tools, in our case, specific to data analysis. And then, as I stated earlier, institutional reporting. So being able to provide an insight to the research that is being done here on campus, either for the purposes of grant renewals, to be able to speak to perhaps stakeholders within the government or outside of campus for donors, those types of things. And lastly, this is our general approach to using generative AI tools, specific to Julius in this case. We're using it to quickly transform data into actionable insights, to save time in data preparation and cleaning. As those of you who work with data will probably know, one of the largest time sinks in working with data is preparing that data or for being able to perform analyses or to receive insights from that information. We're using Julius primarily to move from 0 to 1 in terms of our output or our product development. Again, Julius is going to be able to build Python or R scripts so that we might automate aspects of our workflow. There is a lot of transparency in the fact that Julius is first building the script and then providing the data, so we can actually see sort of the work behind Julius and how it is preparing the data, but then also how it's getting to the point of providing an insight or a result. We use Julius often, especially if there are cases where, as I said, we're looking for efficiencies in our processing around data cleaning, et cetera. But we're always going to validate those results, validate the scripts that are going to be used, cross-check the results that are being provided, et cetera. And then lastly, safeguarding private data. So we predominantly work with publicly accessible data. If we're working with researchers that might have private data, we're making it clear to them that as a campus, we do not currently have any license agreements in terms of our access to the data that may or may not be ingested into Julius and then utilized for the processing of the models. And so we want to make sure that we're protecting any sensitive data. Quickly, this is just an overview of our team, our primary members of our Health Research Services team at HSL. So Barry Hayes and myself, our contact information via email is here, and as well as a link to the URL so you can see other examples of our work. Okay, and I can take questions.
Thanks so much, Adam. I appreciate it. And we can get to some questions. I'm actually wondering if you can explain for folks listening what you mean by cleaning data, because we hear that a lot. And I'm wondering if you can give an example of what it means in terms of your work or maybe even more broadly.
Sure. So data is rarely wherever we're receiving that data from. It's rarely when it comes to us in a in a status where we can immediately perform analysis on that work. So there may be aspects of the data that's missing, which would mean that pieces of information that would need to be represented appropriately within the data set might be missing. So we need to either fill in those gaps or at least recognize that the data is missing. And then again, in terms of disclaimers or transparency for our analysis, make sure that it's recognized that portions of the data were missing. The data is not necessarily structured in a way that we can work with it or work with it as intended for particular analyses. So we need to restructure that data or perhaps structure the data depending on what the again what format the data is provided to us. We also another case that we're often dealing with is data may come from multiple sources, and we need to integrate that data into a singular picture, a singular format, so that we can then ask questions across all aspects of the data. And again, that process can take quite some time, depending on what state the data is in when we receive it. So.
Yeah, I know you can talk about this all day because it takes so much of time. It's sort of the 90-10 rule where we spend most of the time. We have another question. I'm going to probably cut us off after this so we can move on to our next speaker. The question is, will we be providing training sessions on Julius AI in the future?
Yes. Plans are in the works for that exactly, and we have certainly already provided some training either internal to the libraries or in collaboration with the Office of Research, and we have plans to do more so across both of those entities. So stay tuned.
Yeah, thanks for that question. We are actively working on that, as Adam mentioned. Thanks so much, Adam. We appreciate hearing about that and everybody's attention on that. And we're going to move to our next speaker. So let's welcome Rolando Rodriguez, who's going to talk about using AI for image-based research projects.
Thank you so much, Michelle. Give me one moment to share my screen. Great. Hi, everyone. My name is Rolando Rodriguez. I'm the Humanities Data Librarian here at the University Libraries. I'm part of the Digital Research Services team that's located inside of Davis Library, which is part of the wider cross-campus library data services that many of us here are part of. And I'm excited to talk to you about some of the use cases that we've had to use AI for image-based research. I want to start by talking about what our use cases have been for AI in our department. In this context, we've been using AI to make accessible media, to make media that we put in some of our digital exhibits more accessible for folks who may be hard of sight or may have difficulty with internet connection to make the site overall more accessible. Further, to make research material that researchers come to us with more easily accessible and searchable. Usually they're scans of documents, and we want to make that into machine readable text that the researchers can then search. And we'll talk about all of these in a moment. And then also improving workflows that we've had in the past. So we've been working with researchers doing all of these things in the past using the tools that were available. So we've been exploring using AI to see how we can improve those workflows and if they're the right tools for the job. Let's start with alt text for images. So making images more accessible on a web platform. I want to first define alt text. If some of us are not familiar, alt text is a brief descriptive text that substitutes a visual element such as an image on a web page, which allows then screen readers to convey that image content, the content of that image to users who may be part of site, or if they're not using a screen reader, they can read the text if for some reason like the internet's not working well, and overall improving the accessibility of that page. In this image, we see that the images that should have loaded on this website aren't loading, and so what we instead see are their alt text. Alt text is also short for alternative text. So the use case for this was a project that we worked with one of our art history professors, Catherine Desplanck. This was a grant-funded project called Inglorious Artist, Art World Satire and Emergence of Capitalist Art Market in Paris, 1750 to 1850. So in this project, Dr. Desplanck wanted to explore the trope of starving artist in the 18th and 19th century French political cartoons. So she was working to create a monograph. As a companion to the monograph, we created a digital exhibit where users could explore the images in that collection. So hosting these images on the website meant that we needed to create 500 alt text for 524 images. And that was a task that by hand would take a group of people quite a long time. So we thought, why don't we see how AI can do in order to create some of this alternative text. So between the images that we had, some metadata that Dr. Desplanck provided us, such as certain subject tags that she had attached to images, so visual components that were important to the meaning of images, alongside information such as when the painting was produced, the author, etc. And then using OpenAI's ChatGPT, we were able to create the alt text for these images and then set it for each of those images on the website's backend, which is the image that we see on the lower end of the screen. I'll note some of the interesting things that came out during this process was that a lot of this, the alt text initially had to be humanly revised. Either we had to correct some of the pronouns. It would assume that all the painters were men, or indeed some of the photos had women as painters, misidentified animals, or the number of people. So it wasn't perfect, but it really drastically improved the timeline that we were able to produce the alt text for. So let's move on to handwritten character recognition. So to define handwritten character recognition, it is the process of turning handwriting from an image to searchable text. I believe Jackie Dean will talk a bit more in depth about this and the work that she's been doing. In our context, we've had multiple researchers come to us with images of archival materials that they've taken, either because the scans haven't been available on that archive site or for whatever reason, and they wanted to be able to ask questions of that, of those material. So we were able to use, in this case, also again, ChatGPT, to take those images of handwritten material and not just transcribe them, but also create searchable text and metadata. So we were able to assign values to what is the call number of this document, what is the main text, what are the dates listed. And then we were able to take that information, that searchable text, into a tool such as Google's Notebook LM, which is a platform where you can upload documents and it will provide an AI assistant where you can ask questions of it. It can create a podcast episode, a lot of really interesting tools. Moving on to optical character recognition, which is a similar process, but we're working with images of typed text. So we're taking text that's in an image and making it machine searchable and usable. So similar to the previous use case, we've also had researchers come to us with usually images of typed archival material that has a lot of information, but it's not easily able to be transcribed or OCR'd, which is the optical character recognition, and to make that text easily searchable. So we've begun experimenting with AI to see how reliably it's able to OCR these documents for us. And we can see here that it's able to do a pretty good job. In this case, it's a pretty easy text page, but they're not all that easy. But for the most part, we found that, it usually gets at least 80% there. I also want to show a hiccup in the process. Sometimes we present the same page and then it thinks that the page is talking about some mathematical theory. It turns out that was because the page that was being uploaded was rotated horizontally and not vertically. And once we rotated it, we got a much better result. So just an example of some of the hiccups that come with experimenting and exploring these AI workflows. And another project, we've worked with a professor, Martin Johnson, who studies film history, and he has this vast collection of scanned cards that document films that were watched during World War I, which give a lot of context to how films impacted culture at that point in time. These are hundreds, tens of thousands, if not hundreds of thousands of cards that have been scanned. We've previously have tried to OCR these cards using tools such as Google Tesseract and other available tools, but now we're re-engaging that workflow and using ChatGPT and other models to, again, not just get the text, but also provide metadata about that text and really be able to make this a searchable corpus that can be shared with the broader academic community. So some concluding thoughts. What we have learned in exploring AI to use with images is that there's a strong need for iteration. Usually in the beginning, the prompts we use aren't perfect. The results we're getting aren't perfect. So improving our prompts, testing different models, and then ultimately seeing where human intervention is needed as part of this cycle. Also, there's a lot of bias in AI. And so that has to be accounted for when we're working with material that has to do with people or subjects that might be a little sensitive. And then also the AI is always improving. We can test out one model one day, next month, the model performs much better. Or sometimes, I will say it's sometimes worse. Sometimes there's bugs. But maybe it's more apt to say AI is always changing. Lastly, what we're excited about. We're excited to save time with a lot of these research workflows which historically have taken a vast amount of time, like Adam mentioned, this cleaning text takes a really large amount of time. Second, making our workflows more accessible. A lot of these workflows have been created in Python using code. We're hoping that with tools such as AI Studio and our partnership with Microsoft and Azure Foundry, we might be able to make these workflows accessible to researchers with low code or no code solutions. And then lastly, creating more accessible text is just a start. But as one of our colleagues, Jason Kasdan from software development has mentioned before, we want to get to creating description that has additional and strong research value. Thank you.
Thank you, Rolando. So now we will turn to some questions. I do want to say it's really fascinating to see that example of the rotated text and what it did. That I would never have guessed that. I didn't quite know what I was looking at. We do have a question here. In converting handwriting to printed text, how much do you need to do in providing samples of the handwriting converted by humans to printed text? Many pages or few? How effective was the conversion as the author's handwriting changed over time?
That's a great question. So I will say the sort of material that we've been working with has more sparse handwritten text. And so it's usually just like metadata about a folder. And sometimes it's text handwriting that's been written around typed text as well. So it's been pretty good from the start with that material. There are other projects in the way that are based with a lot more handwritten text. And in that case, I think we will have to provide some corrected examples of its original transcription to improve those models. I think Jackie Dean is going to be able to speak a lot more to that. I think she's been working a lot more with handwritten text.
Yeah, I'm glad for that curious question, and I agree. Jackie will be able to dig in more on it and answer that. We have time for one more question. How are you providing privacy for the items being used? Is there concern from the faculty about their data feeding into the models?
Yeah, so that's a great question. So a lot of this information if it's data that we don't want to be shared, we would only use it on models that have been provisioned through UNC, that we have UNC access, such as Microsoft Copilot or with our instance of Azure. If there isn't a issue about privacy, then we are able to explore with other models as well. But that's something we're always upfront with researchers about, that depending on the models that we use, the data might be used to continuously train that model or not. And something it's always a continuous part of our conversation.
Yeah, absolutely. Thanks so much, Rolando, for sharing your work around GenAI and the image-based research. And now we're going to welcome our next speaker, Jackie Dean.
Am I sharing the right screen?
Yes, looks great.
Okay, great. Thank you. So Rolando, you've set me up so well for this part of the presentation. I'm Jackie Dean. I'm the head of archival processing in Wilson Special Collections Library. And in Wilson, we are always looking for ways to make it easier for researchers to find and connect to our collections. And of course, transcriptions is one way that we can really do that. And we do give the example of providing searchable transcription of text with digitized images of newspapers a lot, like this front page from the first issue of the Tar Heel, which presented through the North Carolina Digital Heritage Center. And so, like Rolando mentioned, the text of the newspaper has been generated using a technology called optical character recognition. This one not with AI, but this technology, like we were saying, automatically turns images of text into machine readable machine readable text that can be searched and leveraged in different ways. We also in special collections have a lot of handwriting, like we've been talking about. And until recently, there hasn't been this technology that can automate handwriting transcription in the way OCR automated the transcription of typewritten text. And so, as you can imagine, lots and lots of handwriting text can be tricky. Some of it is very legible, like this excerpt from the 1960s diary of Karen Parker, one of the first Black women to attend UNC Chapel Hill as an undergraduate. And some handwriting gets a little harder to read, like this letter dated 1850 from the Cameron family papers. 19th century letters have other features that make them difficult for humans and machines, maybe, like cross-hatching. So this is when correspondents wrote in different directions to save paper. And of course, there's many other kinds of handwritten documents in Wilson Library collections beyond letters and diaries, like this example of an account book from 1838. So you can probably guess that transcriptions are essential for making digitized handwritten content accessible to a wide variety, to a wide audience, and for making these documents machine readable for visually impaired people. And crowdsourcing has become a popular way to generate transcriptions of handwritten documents. You might be familiar with the National Archives Citizen Archivist Program. It's been around for about 15 years, and it supports crowdsourcing transcription of digitized items in the National Archives collections. At UNC Chapel Hill, we use a crowdsourcing platform called From the Page. And our partnership with From the Page was initiated by Carrie Bannon, digitization support technician in the Digital Production Center, back in 2020. So there's a variety of documents from Wilson, digitized and available on From the Page for anybody to transcribe. And many libraries in North Carolina and around the world use From the Page. The owners and developers, Sarah and Ben Brumfield, work closely with library staff to iterate and improve the platform. So we were very interested when last fall From the Page initiated a project to explore artificial intelligence tools to support crowdsourcing the transcription of handwritten documents. From the Page was looking for repositories to develop projects that would test the AI, the features they were developing, and give them feedback. And so they put out a call for partners, and we answered. And to be clear, From the Page does not want to replace human transcribers, but wanted to figure out whether they could use the technology in a way that, these are their words, would enhance accuracy, enjoyment, or productivity for their users. So what do the AI tools look like? Typically, when you transcribe in From the Page, it looks like this. You have a digitized image of the document and a blank window, and you can start typing the transcription into the window. So maybe you're like me and you have some trouble reading handwriting and would like, you would take some help. So you click on the AI Assist link. And you get a view with text mapped onto the image. And it even lets you zoom in closer. And so these text overlays you can see are really not perfect, but can act as an assist to help you puzzle through the transcription. And this is possible because of handwriting recognition technology. From the Page has run the image through one of these tools, and they use one called Transcribus. And like we said, these are relatively new tools that automate this turning images of handwriting into machine-readable text. And they've added another feature called AI text found at the top of the transcribing pane. So when you click on this, a draft of the text is added to the window, and this draft is created by running the transcribus output through ChatGPT. This is really a draft. The tools don't know all these words. And yes, you are seeing thinking emojis in this draft. The tool, the way they have it set up, it puts an emoji anywhere that the AI is unsure of a word. And it also puts this caveat at the top of the draft that lets transcribers know there may be other errors in the draft. There are, in fact, errors in this draft. And so from the page, wanted to make sure that this output is as unauthoritative looking as possible so that a human really has to get involved and edit the output. And so this is really kind of following their philosophy that of the AI supporting humans and not replacing them. So we were really intrigued by this approach and these tools and excited to see how users might interact with them. So we made a project team. We got started last May. You can see it's a pretty big team. It's members from all across different departments and university libraries, bringing a lot of different expertise to this work. We selected 1,500 pages of digitized manuscripts to run through these AI processes. And we set up testing with both experienced archival researchers and those who were not so experienced, maybe with these kinds of documents. So Nancy Kaiser, who's a tech services archivist and one of the project team members, held a series of Zoom transcribing sessions with a small group of very, very experienced genealogical researchers. And these researchers are descended from people represented in manuscript collections held by Wilson Special Collections Library, including the Hawkins family papers. And you can see they have finished all the transcription for the collection. And this group of researchers tried using the AI tools to transcribe the documents. They have a literacy, I mentioned they're experienced, a literacy and fluency with the handwriting and with these kinds of documents. And they did not actually they turned the AI off and didn't really need it as much to do their transcribing work. But another project team member, Saja Wilson, repository metadata librarian, she's pictured here at the front at the podium, led a transcribathon with graduate students from the School of Information and Library Science here at UNC, Chapel Hill. And for some of the students, it was the first time they had encountered transcription of handwriting and documents from this time period, and they actually did find it helpful to have the AI support because it helped contextualize the documents and gave them a starting point to work from. So we also learned what kinds of documents worked well with AI support and what didn't. Narratives like letters and diary entries were well handled by the AI tools, while AI didn't give a lot of support for transcribers working on tabular data, like in this example. But of course, we know the technology is always evolving, and what we can't do now, we can likely do later. So all these transcriptions will be available for the foreseeable future in from the page. They'll also be migrated into UNC Library's digital collections repository and will be preserved and accessible there for the long term. So if you'd like to check this out for yourself, you can go to fromthepage.com. They've got all kinds of navigation and help and assistance. If you want to start doing some transcription, I also have some links to share that might give us a little bit more of a targeted approach. I'm going to put in the chat. Let's see. Two links. The first link is sending you to right into a collection of documents that have been run through the AI tools. So not everything on From the Page has the AI. We've made a selection. And then the second link is a video tutorial that we made. Sarah Carrier, reference librarian in Wilson Library, and Laura Hart, tech services archivist, made together to support new transcribers getting into From the Page. So our hope is that this pilot project exploration sets us up to use this technology in a sustainable and responsible way, and do this as we continually endeavor toward making Wilson Libraries unparalleled resources widely accessible, no matter what format they take. So I look forward to questions.
Thank you so much, Jackie. We have time for a few questions as we're wrapping up our session today. I'm just going to say I'm fascinated by the whole cross-hatching thing. That is not something I was aware of, and I imagine having these tools to decipher that is invaluable. I'm actually going to pull back or go back to the question that was presented to or given to Rolando, because I think it's relevant for you.
Yeah.
The question was about in converting handwriting to printed text, how much do you need in providing samples? So do we provide training data to the model to say, okay, this is what it is? And, is it a few pages or any at all?
Right. So we don't in this case. We're using an existing model with Transcribus. They've trained the model. I don't think it's off the table that we would go in that direction. And we talk about, I showed some examples from the Cameron family papers, and Duncan Cameron has notoriously terrible handwriting. And so we kind of talk and think like, oh, if we could train the AI to read Duncan Cameron's handwriting, we'd really be in business. But that wasn't part of this work with From the Page. We used existing models.
Got it. Yeah, because I think that is an interesting question too, is how effective is the conversion as handwriting changes over time. But again, we're using a model that's different than training the model directly. Let's see if there's other questions that come up. I really liked that you gave the example too of folks that had the experience with it that didn't need the AI assist.
Yep.
And it's like you got a really good turnout for the session with grad students and that they did appreciate it.
Yeah, and so that really encourages us to keep going and do more of this, because we want to make, get rid of barriers and have supports in place so people can do transcription and feel comfortable with it.
Let's see if any other questions come in. Well, thank you so much, and thank you to all of our speakers today. And thank you for joining us for Library Discovery Hour. Special thanks to our friends of the library. We're so grateful for your continued support at the libraries here at Carolina. There's so much to discover about the university libraries. I learned a lot today, and how we enhance the experience of students, faculty, and friends like you. Library Discovery Hour, I'm happy to say, will return in the 2025-2026 academic year with all new programming focused on timely topics, new perspectives, and the work of the university libraries. We look forward to being in touch with you about those future plans and hope you'll join us again. And I hope that everyone has a wonderful weekend.